Okay, so the final little spin on this correlation work is that there may be occasions where rather than giving you a correlation coefficient and critical value, that you're provided with a p-value in the same way we were with the calculated mean hypothesis tests. And what that means is that they're giving you a percentage chance of such a correlation as the calculated one occurring randomly in a parent population which has got zero correlation. So it sounds a bit confusing, it's quite difficult to explain, but hopefully we'll be able to talk it through it as we go through this. So a random sample of 50 pairs of bivariate data produce a product moment correlation coefficient of minus 0.3. And this gives a one-tail p-value of 0.171. So a one-tail p-value of 0.171, let's interpret that first of all. So if we turn that into percentage, times by 100, a 1.71% chance of a sample of any 50 data pairs from the parent population occurring not occurring, what have I said? Means a 1.71% chance of a sample of any 50 data pairs from a parent population having a negative correlation of negative 0.3 or stronger if the parent population had no correlation. So in our parent population of however many large numbers there are of bivariate data that we've sampled 50 from, and our sample of 50 has got a value of R of negative 0.3, the chances of that occurring if I take any other sample of 50, if there is no correlation in that parent population, there's only a 1.71% chance of that actually happening. That's what that is telling us. What is the two-tail p-value? Well, if you've got a one-tail of that, then to get the two-tail, so then we'd be saying about there is some correlation rather than there is negative correlation, would be double that. So the two-tail p-value two lots of that. So 2 lots of 0.0171 is, so that's a 3.4% chance of there being some correlation as opposed to negative correlation. Stating a hypothesis clearly, tested the 5% significance level whether there is negative correlation. So we're interested in negative, so we're going to be doing the one-tail test. between x and y within the parent population from which the value is drawn. So our null hypothesis, parent population has no correlation. Our alternative hypothesis is negative correlation. So parent population has negative correlation. And we're doing a one-tail test at 5% at 5% significance. So we're comparing our 1.71, our p-value, with this critical region. If the p-value is less than the critical region, then we can reject HO in the same way we were doing with the calculated means. So because p-value 1.71% is less than 5%, we can reject HO, i.e. there is evidence to suggest a negative correlation exists within the parent population. Now, in all the textbooks that I've looked at, it's the questions like in the previous examples that they tend to focus on. However, within the syllabus there is this reference to using p-values, so focus more on the other, but bear this one in mind, it could come up.